Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Supporting national security and intelligence missions is critical to the security of the United States. And my guest on this edition of the Ex Terra Podcast is Kevin Kelly, CEO of Arcfield, a company created to solve the most complex and demanding national security and space-related challenges. Kevin, welcome to the program.
Glad to be here, Tom.
Now, as I said there in the introduction, Arcfield was created to, quote, solve the most complex and demanding national security and space-related challenges. So what does that mean?
I think what it means to us and to our customers is that we are focused on some of the more challenging, technically challenging problems that our mission partners in the intelligence community and the space community are faced with, many of which end up being classified because they deal with adversarial nations and systems and subsystems that don't see the public eye very often, but there are ones that have physics challenge, material science challenges, and the typical big data and cyber challenges that you see and hear about throughout our industry.
Well, we're now closing in on the end of the first quarter of the 21st century, which I kind of find a little bit challenging to believe. and as you mentioned, we're entrenched in the information age. So what is Arcfield's approach to management and exploitation of information?
We have, we see similar challenges. It being in the space and hypersonics and cyber domain, we deal with large amounts of information, much of which has a shelf life, a very short shelf life, in fact. And getting information processed, collected, processed, and disseminated in a timely manner is a very key part of the engineering, the modeling, and the analysis that we do day in and day out for our customers. One of the areas that we're really focused on recently is doing as much space-based processing and dissemination as possible to eliminate the need to uplink and downlink, which adds delay to the national security systems. And it ends up being a bit of a choke point, even with the advent of laser comm and some of the higher speed communication systems today. We still have the need to process more data in space and to handle that dissemination on the spacecraft versus doing the uplink and downlink.
So you're talking about things like edge computing and things of that nature that we've been hearing a lot about as a way to process that data.
Yeah, that's a great analogy. So if you think about the terrestrial scenario, doing as much processing on the edge as possible. In this case, the edge is space. So that's where the collect occurs. That's where information needs to be turned into intelligence. And you need to do that synthesis on board the spacecraft, which is challenging.
So what is the advantage of collecting and processing all of that data in space? I mean, you mentioned that it's faster, but is there an additional way, or is there an additional advantage to doing it in space as opposed to getting it on the ground?
I'll give you the answer is yes. I will give you an example scenario to consider, and that is our need to be able to detect a hypersonic missile launched by an adversarial nation that is traveling at, we'll give you a speed, Mach 7 times the speed of sound. And in order to detect its launch, to plot its trajectory, to determine what an appropriate intercept is, and then to affect that missile so that it becomes either inert or to destroy it in space, only leaves you a matter of seconds. Mm-hmm. If you are suffering the uplink and downlink time and doing the ground-based processing and then the dissemination back up to the spacecraft to get to a defeat node that's going to launch a countermeasure, you're going to run out of time very quickly. And so one of the more important things to do in that mission, as an example, and that's one example, is to do as much space-based processing to create intelligence, to identify a target, and to destroy an enemy missile before you run out of time, frankly. It's that simple.
Is there also a way to perhaps collect data that is being transmitted by, I don't know, maybe a Chinese spy balloon? You'd be able to capture that data and make good use of that data for national security?
Yes, you definitely could. As an example, you could do that. But you're bringing up another interesting point to the why do it? Why is it important? Whenever anything happens, Russia starts to amass troops on the border of Ukraine, or a balloon is spotted and starts appearing on YouTube, and people are saying, "Hey, what is this? That's the moon, but what's this?" The American public wants to know, and we invest a lot in our defense and intelligence infrastructure, and they want to know that it's effective. And waiting, or saying I don't know, or saying I'll tell you in a few months, is just not acceptable anymore. So it's really important that we observe as much as we can, and we make intelligent decisions as fast as we can.
Well, intelligence has always been critical to defense and business. And with the explosion of information right now, and in the case of space operations, the bandwidth that can be somewhat limited compared to the data gathered, how do you manage to get useful and credible intelligence?
So intelligence is the synthesis of information. You can collect as much information as your collection systems will allow. And for years, we focused on collecting more and more information. And they said, well, we'll handle it with ground-based processing, and we'll just add more servers and more supercomputers on the ground, and we'll create intelligence that way. There's a very long answer that you probably don't have time for, but it involves being very specific about what target you're looking for. You can't just be the vacuum cleaner in space and pull everything. And you have to be very targeted about what it is that you're trying to collect. You need to understand the phenomenology. Is it imagery? Is it signals? Is it communications? And then what do I need to do in terms of processing to synthesize all that information and create something that's actionable? And the way we look at intelligence is, it's all part of a national security mission to get our country and our allied nations as far left of boom as possible. Let's prevent the bad thing from happening before it happens with the processing of information and the creation of intelligence, so that we can make wise decisions.
We've also heard a lot recently about artificial intelligence, or as some people say, augmented intelligence. What is the role of an augmented intelligence in being able to synthesize the data to create actionable intelligence?
That's a great question. As we talked about the need to do more space-based processing, those processors have to learn. This is what AI is all about. Artificial intelligence is having the processing subsystem learn from the synthesis of data and improve its algorithms autonomously. And if you think about doing ground-based processing or any conventional processing, it doesn't have to be a space scenario. There's a coder, there's somebody involved who's looking at the telemetry of the processing system and say, well, it's not very efficient. Let me try it this way. Let me tweak the algorithm. Well, that human interaction, as fast as a human thinks, is not fast enough. So having the microprocessing system, the data processing system, learn from its own telemetry and improve itself is absolutely key.
Give us a little bit about your background, Kevin.
I'm an electrical engineer. I like to say I'm a gearhead. I've got a long history of supporting the national intelligence community, the defense community, as a contractor. I've spent the bulk of my career working in high-tech environments trying to solve very hard problems. And I like to think about the art of the possible. My focus area was digital signal processing, but as our conversation has wandered, I get into areas of material science, orbital mechanics, weapons, communications is really where I spent the bulk of my career in building custom waveforms, looking at the signal synthesis and ways to enable missions, national security missions, through the application of various different technologies.
Is that something that you had wanted to do since you were a kid, or is it something that you kind of fell into?
I'd say a little bit of both. I've always been very technically minded, technically oriented, interested in how things work. I was that kid that annoyed the heck out of his parents by taking apart everything that they gave me. And they gave me a bicycle. I took it apart. I wanted to see how it worked. They gave me a model airplane, and I took it apart. So I always wanted to see how things work. So it's just part of my natural curiosity. But, I was most interested in aircraft and spacecraft, and was actually headed down an aerospace engineering path in college when I made the shift to electrical engineering, because electronics are in everything, in automobiles and spacecraft and aircraft, and it was more universal and gave me a way to apply my interests across a multitude of different disciplines.
What about the rest of your team? Who works with you?
So I've got a great management team at Arcfield. It's I often brag about them. It's a handpicked management team of industry experts, and I've got Lori Becker, our CFO, who's got a great wealth of experience both in commercial and government contracting, and she's built everything from the service industry, supporting the space and information systems, all the way up through working with a former company. They actually built spacecraft. They had their own manufacturing and supply chain and so forth. John Avalos, our chief growth officer, has got a wealth of experience with some great companies like BAE and Booz Allen and some real juggernauts in the defense industry. Brings a wealth of knowledge about how to build a competent pipeline. Our CIO staff are our IT team, our operations team, both the heads of my main business units, Steve Hyde and Mark Thompson, are seasoned professionals that know their customer missions really well, and they know how to make sure that we're delivering the most effective solutions. And I could go on, but it is the most experienced leadership team I've worked with from a breadth of experience, and from a technical aspect, bring a lot to the table.
I'm talking with Kevin Kelly, CEO of Arcfield, on the Ex Terra Podcast. Take a moment right now to click subscribe to make sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Kevin, data security right now is more critical than ever. How does Arcfield mitigate data security risks?
There's a couple of areas, and we are certainly not all things to all people. When it comes to data security, there is this concept of cross-domain solutions where you have autonomous systems that allow networks to communicate at different classification levels. The traditional method for data security is data separation, moats and walls, keep things separate. Lots of firewalls, don't let the networks interact. If you have a top secret or a secret or an unclassified network, these networks shall never touch one another. The electrons can't flow back and forth. Just not practical. As I talked about the need for speed and high capacity analytics, the ability for those networks to interoperate with one another becomes very critical. And so one of the areas that we apply our solutions is cross-domain solutions, meaning we can connect these networks with an autonomous system that does data filtering and does not allow classified information to spill out onto unclassified networks, or to do very detailed filtering at line rate to make sure that information is parsed and routed appropriately and it doesn't become compromised along the way. And that's an area where we apply data security in the work that we do.
We've talked mostly about the emphasis on the defense side of your business. Are you also involved in the commercial aspect of the space industry? And if you are, how so?
Yeah, to a lesser extent. We do not have any commercial customers, but you cannot talk about space, cannot talk about defense without talking about the role that commercial companies and commercial technologies play in that environment. So we all know that SpaceX and Blue Origin and a variety of different commercial space endeavors are seeking to enter into the high density, low Earth orbit environment, mostly for providing broadband and communication services globally to unserved areas. If you think about the needs of the government, they have very similar needs. If you think about a military unit that's deployed somewhere in the world and they need communications, the likelihood that those commercial systems will be used is becoming greater and greater. So part of what we do is modeling the interaction between government-only systems and those commercial systems to make sure that our taxpayer gets the best use for their money and that we can take advantage of those commercial systems to a great extent. But again, they're not customers of ours. We need to be aware that they're there, and we need to find a way to leverage their capabilities in serving the government mission area.
Strategists like Peter Zand and even Elon Musk have talked about the demographic decline, if not the overall collapse in many countries. Do you have trouble finding good talent And do you foresee that that's going to be a problem in the near term, say over the 5 to 10 year future?
Yeah, I'd be kidding you if I said otherwise, but it is difficult. What we need in terms of high-tech capabilities, high caliber performers in information security and in communications technology, in the different phenomenology that is involved in everything that we do from IT all the way up to the spacecraft, are the same skills that the finance industry is looking for, that the medical industry is looking for, the pharmaceutical industry is looking for. So we're all competing for the same talent. So it is challenging. We also have, we're not immune from, price and cost sensitivity as well. Most industries are dealing with the same thing. So when we seek to find that that top-notch data scientist and extract them out of the automotive industry, we don't have limitless capability when it comes to compensation or rewards and the like. So it continues to be a challenge and something that I think the industry as a whole in the government contracting industries remains very focused on finding key talent, attracting them, retaining them, and providing rich and rewarding careers so that we can make good use of them in solving these hard problems.
Are you finding that the young engineers are coming out of school with the skill sets that you need to make your business go and to also do the kind of hardcore data analysis and all the technical things that are required to make your business thrive?
They absolutely are. And I get criticized by my colleagues for saying what I'm about to say, and that is the engineers and computer scientists that are graduating today are much smarter than we were when we graduated. They're just more experienced and they have a greater breadth of knowledge about technology in general. So that's good news. One of the challenging things in the national security and defense environment is that education is a global business, right? And one of the great exports that the United States has is a higher education. So the best and brightest from around the world, many of them come to the United States to get their bachelor's degrees and their master's degrees in these technical disciplines. Well, much of what we do requires some level of security clearance, and that limits who I can hire. I have to hire U.S. persons. And so if there's, 30, 40, 50% of a graduating undergraduate class that are non-U.S. citizens, they are automatically off the list in terms of entering into my industry, into the defense and national security industry. So that's a little bit of an extra challenge that we have in our industry that you don't see in many others.
Do you see that space technologies is a major or a minor growth area in the intelligence arena?
It is now a major growth area. When I started in the 1990s in my career, it was a big growth area. There was an advent of technology that was really being adapted and adopted into space-based environment. And then for the last, 20 years or so, it's been relatively stable. But the decrease in the cost of launch and the introduction of new miniaturized, power-efficient technologies has really led to a resurgence in the space industry. That, coupled with the national security missions having to focus on large nation-state adversaries where proximity is not going to be favorable, meaning we have to do more from a greater distance, really lends to more space-based solutions. So it's going to continue to be a growth area for at least a decade or so.
Does operating in space present I think what I'm trying to ask is it a more secure environment? Is it easier to protect data that you're collecting and processing in space than it is on Earth?
I'm smiling because the answer is it used to be. We in the United States used to enjoy domain dominance in space, and that's just not the case anymore. Many countries are flying different spacecraft, and they have lots of capability. So the threat of cyber attacks in space are a relatively new phenomenon that 10 years ago we didn't have to worry much about, but it's certainly a concern now. And therefore, we build more cyber resiliency and we build more cyber defense and space awareness into into the national systems than we did, say, 10 or 15 years ago.
So how hard is it then to predict what that next cybersecurity threat is going to be, and how do you plan for that?
Yeah, predicting what it will be is just as challenging in space as it is on the ground. The added challenge in space is I can't deploy a technician to go add a piece of hardware or increase the memory or the processing power so that I can increase the cyber defensive posture. So that's the added challenge of space, but that's not unique to the United States. It's certainly not unique to what we do in Arcfield. Everybody's saddled with that same challenge. But I'll say this, the subsystems used in space are very similar. They all have corollaries to terrestrial systems. And what makes the terrestrial systems vulnerable are mirrored up in space. And so the ability to understand what vulnerabilities and what attack vectors might be exploited, I don't feel like I don't feel it's more challenging in space than it is in the terrestrial environment. The challenge is, how do I deploy a better defensive posture in space, because I'm limited in what I can install, how many changes I can make to a spacecraft.
I think, without giving away any state secrets, can you tell me if there's also an offensive component to that? Are we also involved in those kinds of, for lack of a better term, hacking operations on some of our adversaries?
I can imagine, as a country, that we are.
And we'll just kind of leave that sit there, Kevin. I think that's fine. We're just about out of time, though, so I want you to take just a moment and look out, if you will, over the next 10 to 15 years in space commerce and how your company is involved in that, and also in the defense industry, and tell us what you see.
I think one of the key things over the next 5 to 10 years is going to be that intersection between the commercial and the national security space. Those two grew up completely stovepiped from one another, different investment profiles, different business models. That's just not practical going forward. The collision of both the commercial and commerce side of space and the national security space is happening today, and a complete interaction is inevitable. I think that's one of the key areas. The other area, and I've talked a lot about it, is doing more space-based processing. It was not space assets were generally designed and architected to be relays. They weren't meant to be ground stations. They were meant to collect and relay information. Again, architecturally not practical to solve many of the modern day and even future world problems. So we're going to see a heavy investment in quantum computing, in space-based processing, and in data security and defensive technologies in space over the next 5 to 10 years.
Well, maybe one day your company will have an office on a life habitat or some kind of a free-floating commercial space station, and you can just do your work right up there.
That'd be something.
Kevin, thank you so much. We're out of time, but I really appreciate your being with us today.
Great to talk with you, Tom.
Kevin Kelly is the CEO of Arcfield, and that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers, my Galileo through is looking glass. That's for reason. Our dreamer's eyes we gaze into a sense of purpose, know my view. Like finding one